All right. So we are going to start our new unit on triangles. So triangles are my favorite, so I'm super stoked to be teaching this right now. So let's get started off into classifying triangles, okay? So being able to classify triangles is going to be a great foundation to being able to start to actually discover triangles and all the beautiful things they can do. So you can classify triangles by their angle measures. And that's what we're going to do right now. Okay. So you can classify them by their angle measures. So the first one we're going to talk about, notice how all of the angles are congruent. Okay. So all of the angles being congruent, this is an equiangular triangle. Okay, an equiangular. So think of equilateral, those are the same. So this just means that all the angles are the same. Now, all of the angles have to be 60 degrees. Have to. It cannot be anything else. Okay, it cannot. Okay, so if only two of them are 60, the other one has to be 60. Okay, all right, so this next one we're going to talk about, all of the angles are less than 90. So this is an acute triangle. An acute triangle. So think of when we talked about acute angles, it's any angle that is less than 90. So when all of the angles are less than 90 degrees, then it's an acute triangle. Okay. For this next one, 114 is the only number we really need, and that's because that 114 makes this triangle an obtuse triangle. An obtuse triangle only needs one angle that is more than 90 degrees. Okay, it only needs one angle, and that for that case, it is the 114. And then last but not least, you could probably guess this, because y'all are smart cookies. This right here tells us that this is a right triangle. Let me just go ahead and... Okay, so a right triangle. So we can classify the angles, and the only four classifications there are equiangular, acute, obtuse, and a right triangle. Okay, so you can use the angle measures to classify triangle ACD. Okay, ABC, and ABD. So it's talking about, so ABC, so this angle right here, and this angle ABD. So this angle create what kind of pair or what kind of angle? Okay. They form a linear pair. So they form a line. So they form a linear pair. Probably go over that in black because it's so hard to see. So a linear pair. So they are supplementary. Okay. So they are supplementary. And what does supplementary mean again? 180, 180. Okay. So if triangle, the measure of angle ABC plus the measure of angle ABD, so I'm going to trace, so ABC versus ABD equal 180, we determine that through the supplementary word. Okay. Well, we don't know what ABC is, but it gives us what ABD is, and that is 120 degrees. And we know it should equal 180. Well, if we actually subtract that 120 from that 180, we're left with ABC equaling 60 degrees. Okay, so this one is also 60 degrees. Well, if all the triangles in ACB are congruent, then triangle ACB is an equiangular triangle. It's an equiangular triangle. All right, so let's classify each of these triangles by their angle measures. So this alone tells us that this is going to be a right triangle. Okay. Example 2. This one right here tells us that that's going to be an obtuse triangle. In example 3, all of the angles are less than 90, so this one is an acute triangle. All right, so I want you guys to do example 4. Okay, example 4. So remember to follow pretty much the steps. So JKL, so it's wanting this whole triangle. For purple, you're going to classify this whole triangle. For JKM, you're classifying this triangle. And then for KML, you're classifying this triangle right here. All right. Okay, you can also classify triangles by their sides. Okay, by their sides. And that's what we're about to do here. So we learned all the angles and how we can classify triangles by their angles, but now we're going to learn how to classify them by their sides. So this first one, notice how every side length is 5, but also that these tick marks tell us congruence. So tick marks show congruence. Let's remember that. Okay. So because all of those sides are the same, this one is an equilateral triangle. Okay. So this next one, it tells us we have 2 congruent sides. So when we have 2 congruent sides, this is called an isosceles triangle. So let me show you how I actually remember that it's isosceles. Okay. So if we look at the word isosceles, we have SOS right there. Okay. So we're going to take that SOS and we have 2 of the same side, 2 of the same, and then we have one that's different. We have one that is in the middle that is a different value. So that's how I remember it, with the 2 S's and the O in the middle. Tells us that there's 2 of the same sides and one of that's different, opposite, whatever you want to look at that as, okay? So a triangle with the measure of, with 2 congruent sides, so 2 congruent sides is isosceles triangle. And then when we get into this one, they're all different. So when they're all different, it's a scalene triangle. Okay, so here's how I remember this. When you jump on the scale in the morning, you weigh differently than when you jump on the scale in the afternoon. Okay, because you've ate, you've consumed calories. So you're going to weigh different in the morning than you do in the afternoon. So in order to remember that scalene triangles have different sides, just think about the fact when you weigh yourself in the morning versus when you weigh yourself in the afternoon, the scale is different. Okay. So let's use this to our knowledge right here. Okay, so step 1 says find the value of X. Okay, so if we look at this triangle right here, we have these tick marks. These tick marks tell me that this is an equilateral triangle, meaning that all the sides are congruent. Okay, so in order to find what the value of X is, which it tells us right here, we need to set these equal to each other, which is what it did in step 2. So it set JK equal to 4x plus 6 because those are the values we have. It plugged in the values and solved for x. So all it did was subtract 4x, and it's left with x equals 6. Okay? Well, now that we know what x is, our step 2 is to plug in x. So we want to know what the value of our side lengths are. Well, we just plugged it into 5 times x, which the value of each side is 30. So each of these sides is 30 units long. Okay, so example 5. We're going to classify each triangle by their side lengths. So we have EFG. So this whole triangle. Okay, so notice how we have 2 tick marks. We have these 2 tick marks and these 2 tick marks. But we don't have any tick marks on this side right here. So this allows me to know that EF is congruent to GF. So EFG is actually an isosceles triangle. Because SOS. We have 2 of the same, 1 that's different. Okay, so EFH, this N1. Okay, Okay, so we have the 2 tick marks. We have this 1 tick mark. And then we have the 17. Okay, well, I'm going to look right here and notice that this value right here is 15. Okay, so that means that this is 15. And this value right here is 23. So this one's 23. All right, and the reason why that segment right here is 15 and this one's 23 is because of our tick marks. So because this value of 15 has this tick mark right here and there's only 1 tick mark, wherever there's 1 tick mark, that value is also 15. So HF is also 15. So that means that since GF is 23, then EF is 23, okay? Well, let's go ahead and add these right here, okay? 15 plus 17. Okay, so we know what the whole value is right there. Just because it's good to know what is all of our values, what all our values are. So this one is 32. Okay, so that kind of solidifies that our triangle EFH or EFG right here was an isosceles triangle because EF was 23 and so is GF. But the hypotenuse right here, this longest side, I guess it's not a hypotenuse, but the longest side right here is 32 units long. So now we want to classify EFH. Well, EFH has a value of 17, 15, and 23. So what is it when all the values are different? And that's how you would classify a triangle with different sides. Okay, so you're going to classify EFH. And then you're going to classify HFG. Okay. So HFG has a 15, another 15, and then a 23 as well. Okay. So classify HFG as well. All right, so let's get into actual algebraic expressions. Okay. So in example 6, we have a triangle that has 3 congruent sides. So that means it is an equilateral triangle. Well, our agenda here is to find x and then the value of one side. Okay, because we only need one side since all the sides are congruent. So in order to figure out what x is, so when you figure out what x is, we need to solve for x by setting these equations equal to each other. And let me tell you why. These side lengths are equal to each other. Therefore, their values are equal to each other. Okay? So now we need to solve for x. So we're going to subtract 4x. I'm left with x plus 1 equals -1. And then I'm going to subtract negative or a 1. And I'm left with x equals -2. Now, this is a once in the blue moon kind of thing, x being a negative, but we're going to roll with it, okay? So in order to figure out what the value of one of the sides are, we're going to plug x in. So we have 5 times -2 plus 1. And that should equal -9. All right, so this last problem, notice how we have 2 tick marks again. Okay, so we only have 2 tick marks. And that means that this side length right here with 2x plus 3 is actually a different value. So in order to find x and what x is, I need to set 3x plus 3 equal to x plus 7 to find what x is. And then in order to actually find out what the side lengths are, I need to plug it into x plus 7 and x plus 3. Okay, so once you find x, you're going to plug it into this one and this one to find both values of the side lengths. Okay, bye guys.